Imagine a fingerprint, not from a crime scene, not from a database, but from 2,400 years ago, pressed into warm tar by someone who built a boat, sailed across open ocean, and died in a battle so fierce that the victors sank his vessel in a bog as an offering to their gods. That fingerprint exists, and it was just discovered. In December 2025, a team of archaeologists announced something extraordinary. Hidden in museum archives for over a century, untouched, unstudied, forgotten, were fragments of tar from Scandinavia's oldest plank boat. And pressed into that tar was a partial human fingerprint. For 100 years, we have asked, who built the Hjort boat? Where did its warriors come from? Why did they attack the island of Arles? Today, we finally have answers. To understand the fingerprint, you first have to understand the boat. In the 1880s, peat diggers on the Danish island of Arles made a startling discovery. Buried deep in the Hjort bog, preserved by the unique chemistry of the peat, was an ancient vessel. Now, before we go further, you need to understand what peat bogs do. They're not just swamps, they're time machines. Peat forms in waterlogged conditions where organic matter can't fully decompose. The water is acidic, oxygen-poor, and filled with tannins from decaying plants. This creates a preservative environment so effective that bodies buried in bogs 2,000 years ago still have skin, hair, and fingerprints intact. Archaeologists call them bog bodies. The Hjort bog did the same thing to the boat. While most ancient wood rots away within decades, this vessel remained sealed in peat for over 2 millennia, frozen in time like an insect trapped in amber. Formal excavations began in 1921. What emerged was unlike anything ever found in Northern Europe. The Hjort boat is nearly 20 meters long, about 66 feet. To give you perspective, that's longer than a city bus. It could carry up to 24 paddlers, along with their weapons and gear. It was built from lime wood planks, lashed together with cordage, not nails. This made the hull flexible, able to ride the rough waves of the North Sea and the Baltic. The construction technique was remarkable. Instead of rigid joints, the builders used plant fiber rope threaded through holes drilled along the plank edges. Think of it like sewing fabric together, but with wood. This gave the hull the ability to flex and twist with the waves, rather than fighting against them. Modern naval architects have studied this design and found it's actually more seaworthy than many rigid hull boats from later periods. But here's what makes the find truly remarkable. When archaeologists excavated the boat, they found enough weapons to outfit 80 warriors. Iron spear points, 138 of them, swords, wooden shields, far more than could have fit inside the vessel itself. The conclusion was clear. This wasn't a single boat. This was an armada, at least 4 boats, carrying a small army of invaders. They crossed open ocean, attacked the island of Arles, and were defeated. The victors, giving thanks for their deliverance, sank one of the enemy boats and all their weapons into the bog as a sacrificial offering. This was a common practice in pre-Roman Scandinavia. After a battle, the winners would take enemy weapons, spears, shields, swords, and throw them into sacred waters, lakes, rivers, bogs. It was a gift to the gods, a thank you for victory. But it also sent a message. Your warriors are gone. Their weapons belong to the spirits now. But for 100 years, no one could answer the obvious question. Where did these invaders come from? The weapons found in the boat were common throughout Northern Europe during the Iron Age. The same spear points, the same shield designs appear in Germany, Denmark, Sweden, and the Baltic Islands. The artifacts gave no geographic signature. Let me explain why this was such a problem. When archaeologists find ancient objects, they usually look for stylistic markers, unique designs, manufacturing techniques, raw materials that can link an artifact to a specific region. A pottery style from one village, a metalworking technique from another. These are the fingerprints of ancient cultures. But the Hjortspring weapons were generic. They looked like thousands of other weapons from the same period scattered across Northern Europe. It was like finding a modern hammer and trying to figure out which country it came from. The design is too universal to pinpoint. Scholars propose theories. Maybe they came from northern Germany, just across the Baltic. Maybe from a different part of Denmark, a rival chiefdom. Maybe from the island of Funen, or Bornholm, or Gotland, places with known seafaring traditions. Some even suggested they came from as far as modern Poland or the Baltic states, but no one knew. For a century, the Hjortspring boat kept its silence. The boat itself couldn't be dated using modern methods. When it was excavated in the 1920s, conservators treated the wood with alum and polyethylene glycol, chemicals designed to preserve ancient wood by replacing water molecules in the wood cells. It worked beautifully. The boat still sits in the National Museum of Denmark, looking almost like it did the day it was built. But there was a cost. Those chemicals make radiocarbon dating impossible. Radiocarbon dating measures the decay of carbon-14 in organic material. But the conservation chemicals contaminated the wood so thoroughly that no lab could get a clean reading. So the boat sat in the museum, beautiful and silent, refusing to tell us when it was made, until 2024, when a team of researchers decided to look where no one had looked before. Dr. Mikael Fovell, an archaeologist at Lund University in Sweden, and his colleagues had a hunch. They knew the original excavators had collected unconserved material, fragments of cordage, scraps of caulking tar, that had never been studied. But where were they? This is where the story gets interesting, because the discovery wasn't made with a shovel. It was made with paperwork. They went to the National Museum of Denmark and began reading old correspondence, letters between archaeologists from the 1920s, shipping manifests showing where excavation materials had been sent, storage inventories listing boxes of artifacts moved from one facility to another over the decades. Think about what museums looked like in 1921. No computers, no barcodes, just handwritten ledgers and filing cabinets. Materials got moved around, reorganized, forgotten. A box labeled Hjortspring tar fragments might sit in a basement for 50 years, then get shifted to a new storage facility, then moved again during a renovation. The researchers spent months tracking these fragments through a century of museum bureaucracy. They followed paper trails through world wars, through museum reorganizations, through changes in cataloging systems, and then they found them. Boxes of material from the original 1921 excavation, untouched for over 100 years. Inside, fragments of limebast cordage, the rope used to sew the boat's planks together, and pieces of caulking tar, the sealant that made the vessel watertight. These fragments had never been conserved. They had never been analyzed. They were time capsules waiting to be opened. And that's why they were valuable. Because they hadn't been treated with chemicals, they could still be radiocarbon dated. They could still be chemically analyzed. They were pristine samples from 2,400 years ago. The research team deployed the full arsenal of modern science. First, they sent a fragment of the cordage for radiocarbon dating. The result came back: 2,195 plus or minus 35 BP, calibrated to between 381 and 161 BCE. For the first time, we had an absolute date for the Hjortspring boat. It was built in the 4th or 3rd century BC, the pre-Roman Iron Age. This confirmed what scholars had suspected, but could never prove. But now, let me tell you why this date is significant. This was the era just before Rome began expanding northward. Julius Caesar wouldn't invade Gaul for another 250 years. The Germanic tribes were still centuries away from their conflicts with the Roman Empire. This was the deep Iron Age, a time when Northern Europe was a patchwork of small chiefdoms, trading networks, and constantly shifting alliances. It was also the era when long-distance seafaring was becoming more sophisticated. People were learning to navigate by the stars, to read weather patterns, to build boats capable of crossing open ocean. The Hjortspring boat represents one of the earliest examples of this technology in Scandinavia. Next, they analyzed the caulking material using gas chromatography and mass spectrometry, GCMS. Let me explain what this does. GCMS is a technique that separates a substance into its individual chemical components and identifies each one. It's like taking a cake and figuring out exactly what ingredients went into it. Not just flour and sugar, but the specific type of flour, the molecular structure of the sugar, even trace compounds from the baker's hands. When they ran the tar through the GCMS, they found it was made from a mixture of animal fat and pine pitch, dried sap from pine trees. The result surprised everyone. Why was this surprising? Because Denmark had almost no pine forests during the first millennium BCE. The Jutland Peninsula, where the boat was found, was dominated by birch, oak, and alder. Pine was rare, almost absent. Let me give you some context. Archaeologists have studied ancient pollen samples from Danish bogs. These samples act like a botanical time machine, showing what plants grew in different regions at different times. In the pre-Roman Iron Age, less than 5% of Denmark's tree cover was pine. Most pines grew on sandy, nutrient-poor soil near the coast, places humans avoided. If the boat had been built in Denmark or northern Germany, it would have been caulked with local materials: linseed oil, tallow, maybe birch bark tar. All of these were common and readily available. But pine pitch? That required access to extensive pine forests. That meant the boat came from somewhere else, somewhere with abundant pine forests. The researchers looked at pollen records and vegetation maps from the Iron Age. The closest region with significant pine cover was east of Denmark, the coastal areas along the Baltic Sea, the islands of Bornholm, Gotland, Åland, the shores of modern Poland, Lithuania, Latvia, southern Sweden, Scania, Blekinge. In these regions, pine covered 30 to 50% of the landscape. Pine pitch was the obvious choice for caulking boats. It was waterproof, flexible, and abundant. The warriors who attacked Als came from the east. They sailed hundreds of kilometers across open ocean to launch their raid. This wasn't a local skirmish. This was organized, premeditated warfare, evidence that the Viking tradition of seaborne raiding has roots going back 2,000 years before the Vikings. Think about the logistics involved. 4 boats, 80 warriors, weapons, food, water, navigation across open ocean without compasses or maps, coordinating an attack on a defended settlement. This required planning, leadership, shipbuilding expertise, and most importantly, it required a reason. People don't cross hundreds of kilometers of dangerous water on a whim. What drove them? We don't know. Maybe it was revenge for a past raid. Maybe it was a struggle over trade routes. Maybe it was just the lure of plunder, livestock, grain, captives, bronze. Whatever the reason, they came prepared to fight, and they lost. And then they found something no one expected. While examining the caulking fragments under magnification, researcher Sahel Ganji noticed a pattern on one piece of tar. Ridges, whorls, the unmistakable impression of a human finger. At first, they weren't sure what they were looking at. Ancient tar fragments are often irregular, covered in impressions from tools, from wood grain, from handling during excavation. But this was different. The pattern was too regular, too precise. They took the fragment to Lund University's 4D imaging lab and created a high-resolution X-ray tomography scan, essentially a 3D CT scan of the tar. This technique uses X-rays to build a digital model of an object's internal and external structure, accurate to within micrometers. When the scan finished, there was no doubt. There it was, a partial fingerprint preserved for 2,400 years, pressed into warm pine tar by someone who worked on the boat. Let me describe what they saw. The fingerprint shows a clear whorl pattern. The ridges spiral inward toward the center, one of the 3 main fingerprint types. You can see individual ridge details, bifurcations where one ridge splits into 2, ridge endings where lines terminate, even some pore structures where sweat glands opened onto the skin surface. In modern forensics, these features are called minutiae. They're unique to each person and form the basis of fingerprint identification. But for a 2,400-year-old fingerprint, there's something else. Proof that this person really existed. Who was he? We cannot determine exactly who left the fingerprint the way that modern fingerprint analysis can, the researchers explained. But it was almost certainly left by one of the crew members, perhaps during a repair at sea, pressing warm caulking material into a leaking seam between planks. Picture the scene. The boat is taking on water. Maybe they hit rough seas crossing the Baltic. Maybe the hull flexed too much in heavy waves and a seam started to open. Someone grabs the tar. They would have carried spare caulking material on long voyages, warms it over a fire, and presses it into the gap with his thumb. He pushed hard, hard enough to leave a permanent impression, hard enough that 2,400 years later, we can still see the ridges of his skin. Michael Fauvel described the moment of discovery. Finding a fingerprint on the tar fragments from the boat was a big surprise for us. Fingerprints like this one are extremely unusual for this time period. To find one on such a unique boat is extremely special. A few other ancient fingerprints have been found in tar, in clay, on pottery, but they come from different periods, different contexts. Roman brickmakers left fingerprints in clay tiles. Neolithic potters left thumbprints on ceramic vessels. But this one is unique because it connects us directly to Scandinavia's earliest seafarers. The people who built and used the oldest plank boat in Northern Europe. First, the Spring boat dates to between 381 and 161 BCE, the pre-Roman Iron Age. This makes it the oldest known plank boat in Scandinavia and one of the earliest examples of sophisticated boat-building technology in Northern Europe. Second, the boat was caulked with pine pitch, which means it was built in a region with pine forests, most likely the Baltic Sea coast east of Denmark. The chemical signature of the tar points to Gotland, Bornholm, or the southern Swedish coast as the most probable origins. Third, the warriors who attacked owls traveled hundreds of kilometers across open ocean. This was not a spontaneous raid. It was organized, planned, executed by people who knew how to build seaworthy vessels and navigate dangerous waters. This pushes back the timeline of organized seaborne warfare in Scandinavia by centuries. Fourth, a human fingerprint survives in the tar, a direct, tangible link to the people who lived this story. Ole Kastholm, a specialist in ancient Scandinavian seafaring at the Roskilde Museum, commented on the findings. We have a modern tendency to underestimate the people of the past and their achievements, but they actually rowed and paddled in small, open vessels across the North Sea, Skagerrak, and the Baltic Sea. He's right. We often imagine ancient people as primitive, limited by their technology. But the Spring boat proves otherwise. These were skilled engineers, experienced sailors, and organized warriors. They built boats that could survive open ocean crossings. They navigated without compasses or charts. They coordinated multi-boat raids across vast distances. They were not primitive. They were our equals, working with different tools. Kastholm continued. The study also shows how important it is that we take care of old artifacts in our museum collections. When the Spring boat was excavated in 1921, one could not have known that 100 years later there would be highly specialized methods that could extract knowledge from even the most insignificant pieces from the excavation. This is a crucial point. Museums often face pressure to discard unimportant artifacts, fragments, scraps, pieces that don't look impressive on display. But as this discovery proves, today's insignificant scrap might be tomorrow's breakthrough evidence. Those tar fragments sat in storage for a century. No one displayed them. No one studied them. They were just there, waiting for the right technology, the right questions, the right researchers to come along. But stop and think about this for a moment. Someone pressed their finger into that tar 2,400 years ago. Maybe they were nervous, about to sail into battle. Maybe they were just focused on the work, making sure the boat wouldn't leak when the waves hit. They had no idea their fingerprint would survive. No idea that in 2025, we'd be looking at the ridges of their skin, reconstructed in 3D, analyzed in a laboratory halfway around the world. Here's what gets me. That person probably died in the battle. Their boat was sunk as an offering. They never went home. But a piece of them survived. Not their name, not their story. Just this, a thumbprint in pine tar. What do you think that felt like? To be one of those warriors, rowing across the Baltic Sea, knowing you might not come back? What drives people to cross hundreds of kilometers of open ocean to fight on a foreign shore? Think about it. These weren't professional soldiers with backup plans. They were farmers, fishermen, craftsmen, people with families waiting for them. In the pre-Roman Iron Age, warfare wasn't a career. It was something you did when your chieftain called. You dropped your plough, picked up your spear, and hoped you'd come back to finish the harvest. And they chose to get in a boat and paddle toward uncertainty. Maybe they were promised glory. Maybe they were seeking revenge for a past raid. Maybe they were desperate, fleeing famine, overpopulation, political collapse. Maybe they were young and thought they were invincible. We'll never know. But we know they made the choice. We know they crossed the water. We know they fought. We know they lost. And we know that one of them, in a moment of practical work, fixing a leak, pressing warm tar into a seam, left a part of himself behind. I don't know about you, but that kind of courage, or maybe desperation, hits differently when you realize one of them left a fingerprint behind. Because it's not just history anymore. It's personal. That fingerprint connects us across 2,400 years in a way that no sword or shield ever could. Objects are abstract. They could have belonged to anyone. But a fingerprint? That's individual. That's human. That's someone who felt the cold wind on their face, tasted salt spray, felt their heart pound as the enemy shore came into view. That's real. The mystery isn't fully solved. The researchers have more work to do. They are now studying X-ray scans of the wood, looking at tree rings. If they can match the ring patterns to specific regions, they might pinpoint exactly where the trees were cut down. Tree rings are like barcodes for ancient wood. Each year, a tree adds a new ring, and the width of that ring depends on climate conditions. Wet years produce wide rings. Dry years produce narrow rings. By matching the pattern of rings in the Hjortspring boat to reference databases of tree rings from different regions, researchers might be able to say, this tree grew on Gotland, or this tree came from the coast of southern Sweden. It's detective work at the microscopic level. They are also attempting to extract ancient DNA from the tar. The same caulking material that preserved the fingerprint might also preserve genetic material from the people who handled it. Here's how this works. When someone touches warm tar, they leave behind skin cells. Those cells contain DNA. In most conditions, DNA degrades quickly. Sunlight, bacteria, oxygen all break down the genetic material. But tar is a preservative. It's acidic, oxygen-poor, and antimicrobial. Some of the same conditions that preserve bodies in peat bogs. If the researchers can extract viable DNA from the tar, and that's a big if, they could learn remarkable things. They could identify the person's ancestry. Were they related to modern Scandinavians? Were they part of a population that later migrated elsewhere? They could learn about their health. Did they have genetic markers for certain diseases? Did they have adaptations for cold climates or specific diets? They might even be able to reconstruct what the person looked like. Hair color, eye color, skin tone, facial structure. Imagine that. A 3D reconstruction of the face of someone who died 2,400 years ago, based on DNA extracted from a fingerprint in tar. Mikkel Fauvel. We are hoping to be able to extract ancient DNA from the caulking tar on the boat, which could give us more detailed information on the ancient people who used this boat. And honestly, I need to know what they find. This isn't just academic curiosity. This is about connecting with real people who lived real lives in a world so different from ours that it's hard to imagine. But when you look at that fingerprint, at the whorls and ridges pressed into tar, suddenly The distance collapses. That person becomes real. So here we are, a boat sunk in a bog 2,400 years ago, a fingerprint pressed into tar by someone who never imagined anyone would find it, a mystery that lasted a century, solved by scientists who knew where to look. The warriors who attacked owls came from the east. They sailed across open ocean from somewhere along the Baltic coast. Gotland, Bornholm, southern Sweden, maybe even further. They crossed hundreds of kilometers of dangerous water in open boats. They brought weapons. They brought courage. They brought hope for victory. They were defeated. The locals, the people of Owls, won the battle. And in gratitude to their gods, they took one of the enemy boats, loaded it with weapons, and sank it in the Hjortspring bog. An offering, a thank you for deliverance. And one of the invaders, repairing a hull, pressing warm pine pitch into a seam, left a part of himself behind. That fragment of tar sat in a museum archive for over 100 years. No one studied it. No one knew it existed. It was just a piece of debris from an old excavation, boxed up and forgotten, until 2024, when researchers decided to look. The fingerprint cannot be identified. We will never know his name. We'll never know what he looked like, what he sounded like, what he was thinking as he sailed toward Owls. But we know he existed. We know he sailed. We know he touched this boat. We know the ridges of his skin pressed into warm tar on a cold day 2,400 years ago. And now, 2,400 years later, we know his story. This is why archaeology matters. It takes the forgotten fragments of the past, a piece of rope, a scrap of tar, a fingerprint, and reminds us who we were, and maybe who we still are. Because at the end of the day, we're not that different from that warrior. We make choices, we take risks, we hope for the best, we leave traces behind, even when we don't mean to. And sometimes those traces survive. If they pull DNA from that fingerprint, if we learn who this person actually was, where they came from, maybe even what they looked like, I'm making a follow-up video immediately. This story isn't over. The research is still happening. More discoveries are coming. So if you want to find out with me, hit subscribe. I'll keep you updated as this story develops. And before you go, tell me this. If you could ask one question to the person who left that fingerprint, what would it be? Were they scared? Excited? Did they think about home as they sailed toward Owls? Did they know they might not come back? Did they have a family waiting for them? Were they young, old, experienced sailor, or first-time raider? Drop your answer below. I'm genuinely curious what you're all thinking, because that's what this is really about. Not just the science, but the connection. That fingerprint isn't just evidence. It's a bridge across time. Stay curious. I'll see you in the next one.